Now, what we look at here is we'll look at the content library, we look at services, and then passive housing. And over here, we'll look at the introduction to passive housing. Now, passive housing, first of all, the first thing about passive housing is the energy it requires to heat the house is about 85 to 90% less than a traditional house that most people live in this country. Your traditional house, whether it was built in the 70s, 80s, or 90s, what it is, this is the running cost for a normal house in this country. Now, in the future, this is what a normal house is going to be run off. So you can see up along the x-axis or the y-axis here, your energy use, right, the values, and it's measured in kilowatt hours per meter squared. Okay, so how much energy it requires to heat every square meter. Now, what we're looking at here is a passive house, really low. Now, on a traditional house, you have your heating cost, which is the largest amount. You have your domestic hot water. So, for example, if you want to have a shower, you turn on the immersion, that's going to cost money, okay, to heat that water. Then you have electricity then, so all your appliances, including, for instance, light bulbs. So in a passive house, if we want to look at the light bulbs that we use, we have to use all LED light bulbs, which are really low energy. Okay. For example, if we want to buy a new TV, we have to get the most energy efficient TV to put into this passive house. So an energy efficient TV, you're talking about on the sticker on the side of it, probably A plus rated. And the same with, we'll say, washing machines, dishwashers. All appliances come with energy ratings on them. So in a passive house, to me, the standard has to be all probably A plus rated. Now, this here, what a passive house looks like. Now, looking at this, couple things from the photograph that people should be aware of is looking here, the windows downstairs, they're actually full length windows and doors. So it's to get in as much solar gain as possible. Now also upstairs, very large windows. So your traditional house has a lot smaller windows, and the reason you have smaller windows is people don't want to put in a lot of windows because a lot of heat is lost out through windows. So what we have in a passive house, we have large windows, but they have to be really high efficiency. Now if we look at then the roof of the house, we'll notice that we have two types of solar panels. First of all, on the left hand side here, what we have is we have ones for hot water, and then on the rest of the house here we've photovoltaic solar panels, and that's for creating electricity. So what it is, the whole roof here is covered in solar panels. So it just looks like a traditional roof, but we don't actually see any of the slate or any of the tiles. Now, if we move on to the next section here, so the next section here is principles of a passive house design. So looking at the first diagram here, if we zoom in a bit here on it, we look at our traditional house. So in our traditional house, we have your minimum insulation. So current building regulations state that in a cavity wall, it's 100 mil insulation. That's the minimum, that's the building regulation. So if you build a house, you have to put in 100 mil insulation into the cavity. Up in the attic, you have to put in a certain level of insulation to meet, we'll say, the current building regulations. And then, for example, underneath the floor, you have to put in a certain level of insulation. Now, if we look, what else is different in the house? We have our traditional radiator heating the room through convection, where we have air hitting the radiator, getting it heated, rising up, and then as it rises up, cold air rushes in, gets heated up, and it circulates through the room. Artificial lighting, so we have our traditional light bulb here, creating the light. What we have here, our fossil fuel oil boiler, producing CO2. What we have here, our copper cylinder, and then we're getting our hot water from the copper cylinder. So In a traditional house, you turn on the oil boiler to heat the water and heat the house, or you turn on the immersion to heat the water. Okay. Now, in some people's houses, you have an electric shower. That's the electric element in the shower that heats the water. Now, and that's called an active design, right? So that's an active house, how it's being heated. So all of these things have to be put into operation. So if you run out of oil, this is no longer active. Okay. So if we go to passive, so if I was to explain if somebody was passive, that would mean that somebody is just sitting there, probably not moving. So what we have in this house is, we have a passive house that's not moving. But the passive idea is to do with heating the house without using all these mechanical devices to heat the house. So if we look at this design here, first thing we'll notice is it's super insulated, maximum levels of insulation possible. And a lot of the time here we're looking at, for example, in the wall, you'd have a minimum of 250 mil insulation rather than your traditional 100 mil insulation in the cavity wall. Now, if we look at the solar panels, we have a solar panel placed up here that is producing heat for heating the hot water. Then what we've natural daylight coming in, and that's what's heating up the space. We have no radiators, no underfloor heating, and the only heat source that we might have is possibly a wood burning stove. And the reason why a wood burning stove is permissible is wood is carbon neutral. When you burn timber, you're producing CO2. But this CO2 is absorbed by trees. So it means that this wood that you're burning has already taken in more than the CO2 ever that's going to produce itself. So that's why we'll say wood burning stoves are permissible. Okay. Now, next, if we look at the principles of the design, and all of these principles here is pieces that you have to remember about in the exam and things that you have to write down. Now, for example, this passive house design is not new. What it is, you had bathhouses in ancient Rome with large south-facing windows. The reason they had large south-facing windows is that's what heated the water in these bathhouses. Okay, obviously in Italy you have a lot more sun, so what you were doing was capturing all this sun, entering these rooms, and it was basically a greenhouse effect, where you have sunlight coming in, heating the water through radiation, that method of heating the space. So this is how they got the water. For example, in ancient Rome, you didn't have any oil boilers to heat the water in the pools or in the baths. Now, so the principle of the design here, the first principle is how you position your house. So your house should be south facing, where at all possible. Now, they do allow you to go within 15 degrees of south. So that means that you can tilt the house southwest facing or southeast facing, but not directly southwest. It's going to be between southwest and south. It's within 15 degrees. So if we take southwest is off at an angle of 45 degrees, you can only go 15 degrees towards that. Okay, and the reason for that is this sun here rises in the east, rises up here midday in the center of the sky, and then in the evening time setting here. So you want to try and get as much sunlight in the front of the house to maximize the solar gain. So if you're asked about the principles of a passive house, the first thing you do is you position, we'll say, your house with the front of the house south facing with all the large sections of windows there. Also, you'll have a solar panel, and then towards the back of the house, north facing, in a lot of these you plant trees. And you plant trees for shelter to prevent any, we'll say, north winds coming down from the north, which is from the Arctic, cold winds. So if you plant them along north face of the house, what it is, it actually shelters the house and keeps the house a lot warmer. Because what you'll have is, you'll have all these trees planted north facing, the wind will rise over the trees and then over the top of your house. Now, these are bullet points here just to go through different aspects, and we'll go them in further detail in the next few slides. Using the, we'll say, the sun's energy, okay, that's called solar gain, to heat the house, okay, so you're heating the space and you're heating water. So the heating water is through solar panels, heating the space then is through coming in the windows, hitting concrete floors absorbing that heat. Now, the next thing, using the sun to provide light in the home. So, for example, some people might be living in a traditional bungalow. Problems with the main traditional bungalow, you have a long hallway, you have bedrooms either side, and even in the middle of the summertime, that hallway is still dark. And the reason it's dark is there is no window, there's no natural daylight getting into the hallway. So in all these designs here, a lot of these houses are open plan. And we try and minimize the amount of hallways that we have in it. Because if we have hallways, we are going to have dark spaces. Now, using very high levels of insulation to retain the heat. So any heat that is being created in this house, we're trying not to lose any of it. Where possible, we're trying to keep in as much heat as possible. So what we'd look at is, we'd look at the floors, walls, roofs, windows and doors. And we're looking at particularly where you have windows and you have walls and how they join with one another. So the space between the wall and the window will always be taped together before it's plastered over to create this airtight seal. And it's all about creating an airtight house so that no heat, if you have air escaping out of the house through gaps in the building fabric, that means you've also heat that's traveling out with that air. And also, if air is able to escape out, you have cold air able to escape in. So the next point here is use a compact design to reduce the surface area and volume of the house. Now we'll look at that in another slide. It's very easy to see the difference between the ratio compared to surface area and compared to volume. You could have two houses, the same volume, but totally different surface areas. We'll look at that. Air tightness control the heat flow to reduce heat loss. So we've covered that. Then use the heat produced by people and appliances to heat your house. So every person that is alive is running around, walking around at 38 degrees Celsius. So when you have a fever, you probably go up to 39. So what it is, you're producing even more heat when you have a fever. But at between 37 and 38 degrees, if you're walking around, you're emitting heat, because most of the rooms you're in are about, if it's a comfortable room, it's 20 degrees. So what it is, you're already at 38 degrees, so you're losing heat. So if we had a thermal camera and we took a picture of any person, you can see their face would be either yellow or red with the heat. Whereas if you look at their jumper's probably going to be green, shoes probably blue, because probably that'd be the coldest part, because shoes low to the ground, maybe we'll say touching the floor mightn't be that warm in any house. So if you took a thermal image, so what we're doing in the passive design, take that heat from the person and keep it in the house. Whereas in a traditional house, we don't even think about that heat. For example, the appliances. If we put a dishwasher running, dishwasher uses hot water. If you put your hand on the dishwasher while it's running, you'll notice that the dishwasher is warm. That warm surface is emitting out heat. And it's the same with a fridge. If you put a can of Coke into a fridge that has been in your car and is at 20 degrees, the job of the fridge is to take that heat from the can of Coke and to get rid of it. And how it gets rid of it, it draws the heat from it and emits it out through a radiator at the back of the fridge. So that's how it works. Okay, so but we're capturing the heat from the back of the fridge. So if you go home this evening and go to the back of your fridge, put your hand in the back of the fridge, you'll notice that it's warm. That's because anything you put into the fridge job is to cool it down. And it brings it down to 4 degrees. So if we're going from 20 degrees down to 4 degrees, that's 16 degrees that we can use to heat the house. Now, it doesn't work in a traditional house because all that heat is escaping out through gaps in the building fabric, or we haven't enough levels of insulation to keep in the heat. So the more people you put in a passive house, the better it works. So if you were to have a family of a husband and wife and one child, have them living in a passive house, and then take the exact same passive house and put in a husband and wife and 5 children. The 5 children and the husband and wife would have a far warmer house because of the extra bodies that are in the house heating the house. Now, the next thing on passive design, next principle is use energy efficient appliances. So we've covered that. Now, use the lie of the land and planting to provide shelter. So we've looked at the positioning of the house. So what it is, we put it south facing, we put trees at the back of the house. Or if we want other things using lie of the land, you wouldn't place a house up on top of a hill where it's exposed to the elements. You put it in a sheltered area, down in a valley, okay, assuming that it's not on a floodplain. Now, these are principles also to minimize energy loss and maximize social gain. So these are principles. So if we look here, this is the criteria. So to deem whether you have a passive house or not, they look at all of these criteria. So if you fail on any of these, you don't have a passive house. So the first thing is the annual heat requirement. So it's 1.5 litres of oil per metre squared. So if we take this woodochrome, this woodochrome is 138 square metres. So what it's saying here, to heat this woodochrome for the entire year, you take your 138 metres, multiply it by 1.5, and then calculate the costs of a litre of oil. So if we take that, it's roughly 200 litres of oil to heat the woodochrome. And if you take the oil, then say €1 a litre, it costs €200 to heat this woodochrome. Now, this is a large woodochrome, so what it is, if we were to heat it the traditional method, it's probably going to cost maybe 4 times, possibly cost €800. So if we put this into a house, what it is, it's a huge saving for just heating the house. Now, if we look at airtightness, it has to be an airtight house. So you can't have, for example, on some of your houses, you might have 1 or 2 windows in your house with a slight gap where the window isn't closing properly, and if you put your hand up against it, you can feel a breeze coming in. That is not airtight. Now, the main disadvantage of having an airtight house is it does limit you with, for instance, you will no longer be able to have an open fire. You can't have a fireplace. Because if you have a fireplace, you're not going to have an airtight house. Because what it is, all the air will come down the chimney to make sure it's not airtight. Now, if you want to have a wood burning stove, the design is that you bring in a vent, or you put a vent on your house, on the outer wall, bring in a pipe all the way into your house and bring it up next to the wood stove. So you open this vent when you have the stove running. So that will say you have combustion and you have oxygen for the wood burning stove to work. So what it is, that's how you get air into the house if you want to have the wood burning stove. But in a lot of passive houses, you won't even have a wood burning stove. But if you want to have a wood burning stove, and some people, it's kind of a traditional way of heating up, still will want a passive house, but they'll still want to be able to burn something. Okay? Just even if it's just for the effect. What they'll have is, they'll put in this wood burning stove, but they have to bring in a pipe from outside to bring air in. Or else the other alternative is, in the depths of winter, and you don't do that, and you still have, you have to open a window for it to function. But if you're opening a window, it is no longer airtight. Now, the next thing then is super insulated. So we've just done U values. So what you have, your whole house has to have a U value of 0.15. Okay, so that's the U value of the whole house. So we've been calculating out U values for the last couple of weeks. We've got either large U values or small U values depending on house. But the whole house here, for example, the current building regulations regarding walls or regarding the roof of a house or the walls of a house is 0.27. So this is far, far lower. I will look at diagrams showing what U values is permissible. Now, the next thing, no thermal bridges. So thermal bridges is where you have external wall, internal wall, and you have heat escaping out through the internal wall and then escaping into the external wall. So what it is, you can't have any thermal bridges. And we'll look at that in the chapter on insulation when we're looking at thermal bridges. Next, passive use of solar gain through orientation. So that means south facing. Have your house south facing. Compact building design. That's will say you're not going to have a square house and then you'll have a piece brought out on the left hand side. Then you'll decide, oh, I'll put on an extension out the right hand side. And then we'll put on a small porch sticking out the back. That's not going to help with compact design. Then glazing and window frames, U value of 0.8. Now, the 0.8 is probably as low as you can get with windows. Windows are made from a lot of the surface area is glass, and glass is not a brilliant insulator. So the windows in any house is the main area that you're going to lose heat. So in a traditional house, you'll have a U value of 1.6, maybe 1.8. Whereas in a passive house, they have 0.8. Next thing then, A-rated appliances. So you have to have A-rated appliances. Next after that, we'll go on to passive house designs. So just very simply here, if you're asked in an exam to draw the layout, and we'll look at this layout here. So if we zoom in on this layout here, this here, traditional house, what looks like a traditional house. So for example, we have a kitchen area here, we have a dining area here, and then we have the living space here. All open plan. So all this section here is all open plan. We have doorways here, we have windows here, we have another window here. Then what we have here, large playroom here, and then what we have at the back of the house then is bedroom 3, master bedroom with ensuite. We have a utility room, then we have either a bedroom or we'll say a TV. So this could be your traditional 4-bedroom house if we look at this as bedroom 2 and have no playroom. And then we have our bathroom located here. So bathroom, and that services these 2 bedrooms, and you have your ensuite here. Now, all bedrooms, utilities, bathrooms should be north facing because we do not need direct sunlight coming into these rooms heating them. Okay, the main areas of the house that we live in and we spend most of the time is this area here. So this is the area that we want to be the warmest area. Now what we've done here as well is there is a wall constructed here in the middle of the house. This here is the hallway, so it's a very small short hallway, and what you'll notice with the hallway as well is no sharp corners. We have angles cut off here to allow light to enter this hallway here. So this here would be referred to as the back door of the house. So what we have here is we have, we'll say maybe the back door. Now this could also be the front door of the house, okay, depending on how the house is orientated. But what we do know is this area here has to be south facing. So the driveway to the house might be at north facing. Now what we've done here as well, if this is the front door of the house, there is a porch connected here. And it's important that porch is connected here for a passive house. When somebody calls to this house, they come to this door here, they open this door, then they close it after them. Then they knock on the front door. The person from the house then comes to the door, opens the door. The whole reason for this design here is, and for this porch, is the heat that is here, the only place it'll get to is here. It's not going to escape out through into the driveway. So this is another method of trying to minimize any heat that's lost. Next thing then, we have this wall. The whole function of this wall here is to provide privacy. So for example, if we'll say the husband is cooking dinner here, doorbell rings, the wife gets off the couch and goes to the door here. What you have here, the person at the door that might be delivering junk mail or whatever, trying to sell something, what it is, they don't see into the whole house. Okay, because of this wall being placed across here. But this wall is constructed using glass blocks in the center of it. And you'll see this as any building program or design program where you see these blocks used here. The whole function of the blocks is to allow light out into the space. So for example, when it comes to the summertime, there's never a need to put on lights in this house during the summertime. Whereas some people living in traditional houses where you have a long hallway, even in the summertime, you have the lights, the artificial lights working because of the way the house was constructed, the orientation it was set in, and the way that the house is designed with lack of windows to get natural light in. So this whole section here, even in the dark months of November and December and January, there's probably not a huge amount of daylight or natural light needed to be turned on because of the windows that are used. Now, this is a key layout, and it's a good layout to learn off and redraw out in an exam. Because if they ask you to draw a layout of a passive house, this is as simple as it gets to draw out. Okay. Now, if we look at just different ideas, because some people think if we build a passive house, it's going to be really boring looking house. Basically, passive house is probably one of the nicest houses to live in because the minute you walk into it, you'll notice it's very bright inside in it. The reason it's bright inside in it is because of all the glass, all the window sections, and you have these window sections going all the way down to the floor. And the whole thing is you're trying to get the house to have as much daylight to gain as much solar gain as possible. Okay, so these are just different examples of different types of passive housing. Okay, so for example, in this fourth picture here, you can make out where the solar panels are going to be placed up on the roof. So house is obviously in the construction method or construction stage. This house also here, construction method here. You can see the outside isn't finished. Now they have included a section here with a flat roof on it. So the surface to volume area ratio there is not fantastic here. Okay, this one here, a small bit here of this piece coming out here, but it'll probably meet all the criteria. Okay, now if we go on to the features then of a passive house. So if we look at all the different features of a passive house. Right, so in practice, your passive house will have most of the following. So it'll have most of it. It mightn't have all of them. Okay, so rectangular in plan, so that the sun can shine in deep into the house. So the whole advantage of that is, if we go back to vernacular architecture and look at our West of Ireland cottage, the depth of a Western Ireland cottage, you had the front wall of the house, you had the back wall of the house. The house was one room in depth. So it meant that there was no hallways, dark hallways. Light got in the window, went to the back wall. So they had no artificial light. So they were lighting that room using the natural light. Okay, so we're going back to this method. Now, compact in design, so our low surface to volume ratio again. Next thing, position on the site, looked at that. Next thing, south-facing facade with lots of glazing. The next thing then, north-facing facade will have very little glazing. So we minimize it north-facing because what it is, the windows are still the key area of a house you're going to have heat loss. So what it is, we have large windows on the front to get heat in. We're never going to get heat in north-facing windows. because the sun doesn't shine from the north. So you put in small windows at the back of the house, or the north facing section of the house. Now, rooms that are used most of, so for example, living room, kitchen will be on the south side. Then rooms that are least used, utility rooms, toilet, storage, right, north facing. Now, thermal mass. So all of these houses will have concrete. And the reason they have concrete is to absorb the heat from the sun. So they act as a storage heater. So if the house starts to cool down in the evening time, the heat that's in the concrete will be emitted out into the room. And that's your solar gain. And it's a key term that's often mentioned is thermal mass. So how to increase thermal mass in a house design. What you're placing in there is placing in concrete. So that when sunlight hits concrete floors or concrete internal walls, what it is, it's able to absorb it. So this is where a concrete built house has a large thermal mass, whereas a timber frame house won't have as much. But in a timber frame house, you'll have concrete floors, but you won't have any concrete block walls. So what it is, you're going to have to look at, we'll say, having a large concrete area in a timber frame house. Okay. Now, very high levels of insulation to heat. Okay. Airtight structure to reduce heat loss through drafts. Okay. Controlled ventilation is good practice for good indoor air quality. So the next chapter we'll be looking at is, we'll say, a mechanical ventilation heat recovery system. That's how we heat these houses. Okay, and how we bring in fresh air from outside. So an airtight house means there's no air getting in from outside. So we have to create ventilation. So what we do to create ventilation, we need to bring in air from outside. We now, in this method, do it through mechanical means. So we'll be looking at that in the next chapter. Now we have solar collectors for your hot water. So that is looking at your solar panels up in your roof. Now the next section here, this is a very simple sketch that every single person can draw out. So what you have is, you have your solar panels, you have your Velux windows, you have your windows here, okay, all south facing, and this here, north facing. So, and then you just put on notes in, solar panel, north, your sun here, and what they're showing here, sun shining down here, lots of glaze, and then they're showing very high levels of insulation. Now, this is just a sketch to explain the principle. It's not, we'll say, a detailed sketch. Now, the next section we look at here is the shape and form of the house. So these are all things to do with the shape and form. So, shape and form, a deep plan, south-facing, open plan to maximize solar gain. So what we're talking about is, most of the house should be one room in depth. So the front wall to the back wall, one room in depth, so the heat, the light, natural daylight, penetrates the whole house, and also heats the whole house as well through solar gain. The angle of the roof, 45 degrees. It's the optimum angle to put in solar panels at, that they work best at. Okay, so that the sunlight will hit directly on top of them, rather than putting in a solar panel at 30 degrees, where the sunlight will still hit it, it will still function, but it works a lot better if the solar panel is at 45 degrees. So the angle of the roof, best benefit is 45 degrees. Next thing then, maximize the glazing south face, then minimize north face. So we've covered that. Draft lobby or sun trap doors. So what we're saying is, if it's north facing and you have the front door to your house north facing, you put in, we'll say, a porch out of that. And that's to actually trap in any heat and to stop it escaping out if somebody comes to the front door of the house. Okay, and that's what we look at. Next thing then is direct access from sun space to living area. So if your living area is not in the sun space, you've direct access, so it's open plan. So for example, one of the houses designs that we looked at, we've seen that flat roof extension. That's the sun space. So what it is, obviously that's connected to the living space, and all the heat that's being produced there and light goes in through that. So what it is, you wouldn't have a single traditional 800mm wide door there. It would be either double doors out into that are open most of the year round, or actually no doors at all, just an archway to lead out into that space. Next thing then, multi-function kitchen, dining. This is all to do with open plan. Okay, and then the last thing then is compact form to minimize surface to volume ratio. Now, this here is your surface to volume ratio. Both houses have the exact same surface area. So if you had to pay tax, and say if tax was based on your area of your house, and say you're charged €10 for the area. What you have in this house here is you have 1, 2, 3, 4, 5, and 3 up. So that's 15 square meters. So if you were charged €10 for 15 square meters, you'd have to pay €150 tax. Okay? If we look at this house here, it would be the same amount of tax based on the actual area of the house. It is still just 15 boxes placed in here. Now, the issue with this is we're saying you have to minimize the surface area. So if we were to measure the surface area of this house here, what we're looking at here is there's 5 meters across here, then there's 3 meters here, so it's 8, and then another 8 here. So that's 16 meters. So if you have to walk from one corner all the way around the house, you're walking 16 meters. Now, if we look at this house here, it's the same area, but it's got a far greater volume or surface area. Now, the problem with large surface areas is there's more areas for heat to escape. So if we count all the single lines here, so if we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 meters all the way around compared to 16. So it's a far greater space. So there's more chances of heat escaping out through it. And if you take it as if the walls are all 3 meters high, this here would be a far greater surface area. So that's why we try to minimize that and go for a compact design. Doesn't mean you have any less space. It just means that it's, we'll say, a simpler shape. It's compact. Okay. Now, insulation. There's a huge amount when you're, and it's probably the most expensive part of a passive house, is the insulation. Because if we look at the insulation levels here, we're looking here rigid insulation in the external walls extending down to the foundation. Then we're looking at 300mm insulation continued underneath the entire floor slab. And I have a few photographs of this as well to show you all this. Continued insulation at the eaves and walls, we'll look at that. And then the edge of insulation to the ground floor, we'll look at that. And then you've got your triple glazed low E window system. Now, the first diagram, and an easy diagram to look at is, and first thing you'll notice is, this is completely new way of building. So for example, we come to our site, we bring in our machine, clear the site. We put in a bed of hardcore, and then the next job we do is, we start with our insulation. So we don't come in and we tie our steel or anything like that, we start placing in insulation. So what you'll see in this diagram here is you've got 3 layers of insulation underneath the floor. So if we look at each of them, I don't know, it doesn't say here the thickness of it, but say they're 100mm each. So you have 300mm of insulation underneath your floor. Whereas in your traditional house, and most of the houses that we're living in, if we have 50mm insulation, it's probably the most. Whereas building regulations state that you have to have 100mm insulation. In a passive house, it's far greater. And what we're doing is, this slab here, that is your storage heater. That's where you're using for your solar gain. So your direct sunlight hitting this pad. So this is hitting the pad. You do not want any of that heat to escape down into the ground. So that's why there's such a high level of insulation. The other thing as well is, our foundation now is wrapped with insulation. So our foundation doesn't actually touch the ground. And then if we look at this diagram, you'll notice that this diagram has one wall, a lot larger. It's a 150mm wall, and then outside it we place our insulation, and then outside that we have external render. We've no cavity. We don't need a cavity. Now, if we look at the second diagram here, we notice more traditional, where we have two leaves of blocks. You have your external leaf and your internal leaf. We have insulation in between the two. And then what we have is, we have our two foundations. You can see the radon barrier placed in here. Okay, but you'll see two foundations are separated. And we'll see in a few minutes why you need to do that. Now, the next thing then is to reduce cold bridging. So we'll look at cold bridging later on. So window reveals and heads. Then what we have is the top of the wall at the wall plate level. So we'll look at that. Then you have your window sill and we'll say the head of your window. Then you have your junction of your ground and external walls. So we'll look at that. Now, next thing then is design of passive house to stop overheating. And this is a problem with passive houses, is they work so well that in the summertime, if we get a good spell of weather, these houses could overheat because you're getting a lot of heat entering this house through solar gain. So in the summertime, it could be a problem of overheating. So how we minimize that is we extend the soffit and fascia and we create a large overhang so that it creates a shade. And then in the wintertime, that doesn't have the same effect because the sun drops lower in the sky, so it doesn't shade the sun as much. What you can also do is put in blinds and curtains or heavy wooden shutters and pull them across. Other things that you could do is actually plant trees. And plant trees south facing. But the trees that you plant south facing is you plant in some deciduous trees. So that in the winter time, when there's an issue with heating the house, them deciduous trees don't have any leaves on them, so they won't be blocking, we'll say, direct sunlight in the winter time. But in the summertime, you're creating a bit of shade, so what it is, the house won't heat up as much. And that's one way of preventing, we'll say. Now, the other method here is having opening sashes. What that means is have windows that actually open. So if we've an airtight house, it still doesn't mean that we can't open a window if the house gets too warm. Okay? But these houses, what they do is they're so well insulated, they won't heat up as much through the walls as a traditional house does in the summertime. But the only effect we have is because we're not losing any heat, you're getting a lot more solar gain. Next section here is your advantages and disadvantages. So obviously there's an advantage and disadvantage of everything. So looking here, the advantages, your low energy consumption, right? So they say here, typically 75%. Next thing then, comfort level. So this house is 20 degrees all year round. Next thing then, economical, what it is, talking about the cost of running the house, 75% cheaper. And then the next thing, obviously this type of house is a lot better for the environment because we're not burning oil, we're not producing CO2. The disadvantages, and the disadvantages list is a lot larger. And there's a good reason why it's a lot larger. The workmanship. Because you're creating an airtight house, it's a lot harder to build. So the builders that you have doing this have to be highly trained. And obviously it takes a lot longer to build one of these types of houses because it's a slower method. If you have to go around and tape all windows and doors to create airtight, that takes time. Whereas in a traditional house, that was never done. So that house was being plastered at a lot quicker stage. So the tradesmen have to be trained. Precise detailing takes longer. Next thing then, mechanical systems to provide ventilation into the house. So you have to have your mechanical systems in your house. Okay. Next thing then, these filters have to be changed. Okay. Now, other issues with these type of houses that is not up here is this type of house is far more expensive to build because the windows will cost more, the doors cost more, you have far more insulation put into this. Okay. Now, next thing we'll look at is a few diagrams of all these houses. So, these are all pictures of ideas of how you build these type of houses. So we're looking at our one method of just using a single leaf block, placing insulation outside, and then you'll have an acrylic render placed here. on fiberglass mesh to make it watertight. Okay, so there'll be no chance of this ever getting moisture travelling all the way in. This here, your traditional method with your two foundations. Next, this here is what the building site looks like. Whereas if you're looking at, we'll say, a traditional building site, you'll see them taking away the soil, and the next thing then they do is they put in gravel, then they put the steel on top of the gravel, then they pour the concrete. Now what we're looking at in this diagram is you kind of start building it like Lego by placing in all this insulation, and then what takes place is we start pouring our concrete. But that concrete never actually touches the ground underneath. Now, this is all rigid insulation. So what it means is that you're not going to be able to punch holes in it. That will actually withstand, we'll say, the weight and the force of the building acting down on top of it. Now, this here, quite a clever diagram. And what this explains what happened in the 19th century. And the main thing I want to point out is the heat of the house using fires. So in a Georgian house, you had maybe 7 or 8 fireplaces. You had fireplaces in each bedroom. So what you had was, that was your traditional fireplace, probably the worst way of heating a room. But they also wore big jumpers, because none of these houses were that warm. What you have here, this is the current stage that we're at. We're the current stage that we love technology. And we put in every kind of device known to man to heat our house or to do different things. So for example, in the diagram here, you've got heat pumps put in, you've got your oil, you've got, we'll say, radiators on the wall, you've got your oil boiler, you've got, we'll say, electric showers, you've all different methods here. Now, in a passive house and in the future, what we're going to look at is basically going to use the sun. So we've large windows. And what we're going to do, high levels of insulation, and then we do still use a bit of technology. We're going to use, we'll say, the mechanical ventilation system so that we actually get in fresh air into the house. And we're also going to use solar panels to get in, we'll say, to heat our water. But that's it. Next thing that we look at is we look at the passive house principles, and this here is a good diagram to show you. That's our piece of concrete. That's our floor. So that's our concrete floor that doesn't touch the ground. Okay. This here then, the next section we have here is your, now this here is a quadruple glaze. Now, new to the market. Okay. But in a couple of years' time, it won't be new to the market. What you have here is 4 panes of glass. So this here is to try and achieve as best U value as possible. So the only difference between this here and your traditional triple glaze is just an extra piece of glass, an extra probably argon filled section in the glass here. Now what we have here, thermal break in the window frame. And the thermal break in the window frame is the inside of the window, timber that we see, the outside of the window in some material, some cladding that is weather resistant. So could be aluminium, could be PVC, could be any color you want. And between the two of them is an insulation material so that any heat that gets into this does not escape out through your windows. And that's where they're trying to come up with the best section possible to try and minimize heat loss through windows. Okay. Now, the next section you have up here is videos. So you have all these videos to watch in your own time. So this video is actually the first one here. This one here, the air tightness and insulation. So it looks at that. Then we have a video here showing passive housing and showing, we'll say, different details. Okay, showing the windows and actually showing that section through a window, showing how the window is made up. So it's a good video to look at in your own time. The last page here then is looking at if we're asked to draw different diagrams. What I've placed in here, this here, your normal diagram looking at a floor and looking at your traditional foundation. Whereas you turn on the heat, The heat goes through this block, heats up this block. Then the heat starts going down here and continues on down, right? And enters your foundation, and you have heat loss there. What we have here now in the new method of passive house, the first thing is we start using lightweight blocks, insulated blocks, so that heat won't travel through them. So first of all, we don't have heat going down to our foundation. The heat level stops here. Also, what we'll notice in this diagram is the amount of insulation, extra insulation placed in. And then the last detail we should see is air tightness seal. So when we're building this, before this house is plastered, we come along with tape and we tape any joints. So a joint would be where the wall meets the floor. That's a joint. So we come along with tape and we tape that joint. And the reason we tape that joint is so that no air will go between the floor and the wall. And no matter how you build this, if you go with the traditional method, build your wall, then pour your floor on top, your floor will dry out. And when your floor dries out, the concrete dries out, it shrinks a small amount. That means there's a gap between your floor and your wall. And in a traditional house, that's where air will circulate down, and you'll have heat loss down through there. Now, the last couple diagrams here are all these diagrams showing all this detail. Now, these are all in your construction book. So what we have here, and it could come up in an exam that you're asked to do this. Now, what you have, insulation, you have levels of insulation here. The only thing that's really new is the way that the rising walls are built using these insulated blocks. And once you get up to this level here, the radon barrier is still the same detailing. Your concrete screed here, same detailing. Okay. If we look at this here, the only difference in this, it's a timber frame house. The timber frame this time is far wider. Okay, a traditional timber frame house, you have your 150 mm wall. In passive house design, we have far more complicated. For example, we have a 50 mm fibre board placed outside the wall. So then what we have is we have large level of insulation. So what we have, huge amount of insulation here, 200 mm of insulation. Then what we have is we have our sheeting material inside. We have a vapor barrier placed in there. And then on the inside of the wall, we have a plaster slab with insulation stuck onto that. And that's all fixed onto this internal wall. So it's a really complicated detail. And this is why a lot of passive houses now are going back to a more traditional method of using blocks. Because it's an actual easier detail to meet passive housing standard. Now, this section here, the timber frame section, this is still all built in the factory. So it'll arrive on site like this. Now, these are window details, and what you should notice about windows is just the detailing around the window frames themselves. That if we draw out our traditional window frame, still in this shape, but what it is, half the shape now is insulation. You just draw a line through the middle, and that's called thermal break in a window. Then our roof level, what you'll have in your roof level, large amounts of insulation, and what you'll have is you have insulation placed in between the rafters to stop any heat escaping. Okay, and then again we have, even our ceiling is done slightly different. What we've done in our ceiling here is we've put in a vapor check across here, battens onto the ceiling joist, then our plasterboard has insulation stuck onto it and is placed up. And we've also got our airtight seal here, and then to stop any heat loss at the wall plate level, we put in our lightweight, we'll say concrete block again, up in this section here. Okay, so what we have here, this here insulated thermal block here, the whole cavity filled again. Okay, but as for the tiles, the same as before. The soffit and fascia, the same as before. Okay. Now, the last thing we'll have a quick look at is this here, higher level passive house question. What is actually asked? So what is actually asked? The first thing is, discuss in detail any of the two following. So looking at the air tightness of an envelope, that means the building itself, then the heat spacing demand, so how this house is heated, and then the indoor air quality. So indoor air quality, what we'll be looking at in this type of question is looking at the mechanical heat recovery unit. And if you get, this question is basically question 10 nearly every year since, we'll say, they've started asking passive house questions. They will always have a small bit about, we'll say, the mechanical heat recovery unit, because it's the main part of a passive house. Then what we're using here is notes and freehand sketches to discuss the thermal mass in your design or passive house. So looking at the thermal mass in a passive house. Then the last thing then, using notes and sketches, show how solar shading, so how you stop this house from overheating. Now, that's the whole section on passive housing covered. Okay, now there's a lot of detailing needs to be looked at, but all of these are in your OneNote notebook here, right, under the section of passive housing. Now, next week we'll be looking at your heat recovery unit.